Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 elimination requires an antiperiplanar arrangement of the H and the leaving group, Br. In cyclohexane systems, this means the H and Br must both be axial, transdiaxial. The rate of E2 depends on 1. Whether the antiperiplanar geometry is achievable, and 2. The substitution level of the substrate. Moving on to the next step. Structure C shows a cyclohexane with CH3 on a wedge and Br on a bold down wedge at adjacent or same carbon arrangement. Looking carefully, C appears to be a tertiary bromide, 1-bromo-1-methylcyclohexane, where the Br is in an equatorial position or a configuration that allows ready antiperiplanar elimination. Actually, reconsidering the structures, C has CH3, wedge up, and Br, bold wedge down. These are on the same carbon, making it a tertiary system, or they are on adjacent carbons in a trans relationship allowing antiperiplanar geometry readily. In the context of this problem, C is identified as having the best geometry for E2, antiperiplanar H and Br both axial readily accessible, making it fastest. Moving on to the next step. Structure A has CH3 on wedge and Br on dash at the same carbon of cyclohexane. This is 1-bromo-1-methylcyclohexane, tertiary bromide. The conformation can place Br axial with an adjacent axial H, but the geometry is somewhat less favorable than C. It reacts at an intermediate rate. And for the final step. Structure B is a secondary bromide, Br on C2 with methyl groups at C1 and C4. The steric environment and the conformational requirements make it harder to achieve the required antiperiplanar geometry. The bulky substituents interfere with adopting the diaxial conformation needed. This makes B the slowest. CAB, which corresponds to answer choice B. Option A, ABC ignores that C has superior antiperiplanar geometry. Option C, CB incorrectly ranks B above A. Secondary bromide B is slower than tertiary A. Option D, BAC incorrectly places secondary bromide fastest. Therefore, the correct answer is B. Therefore, the correct answer is option B.